Hello and welcome to my YouTube channel FPGA Made Easy. On this channel you will learn about the FPGA technology and programming from basic to advanced level. For more videos, subscribe this channel by click on the subscribe button and follow us on our Facebook page for the notification. This video is very important for the undergraduate, graduate and postgraduate students because in this video we will talk about the research oriented topics in the field of FPGA and programming. In this video, we will discuss about the fault injection technique and how can we develop a fault injection tool for FPGA based designs. So, we carried out our discussion with the FPGA systems followed by fault injection techniques and types. After that, objectives and goals of this technique is described in detail. What are the main components which are required to develop a new fault injection will be discussed. At the end, how a fault injection tool can be used or developed for the FPGA systems. So let's start. Field programmable gate array is most widely used in wide variety of applications such as safety critical application, Internet of Things, military application, digital signal processing and many more applications. Because of the features it provides such as parallelism, reconfiguration, higher performance, low cost, self-healing capabilities, low turnaround time and reduced time to market, and there are many other features. Now we discuss about what is fault injection technique and their types. Fault injection is a well-known technique to evaluate the dependability and testing of FPGA systems. There are four main methods exist in which fault injection is possible, namely hardware-based fault injection, software-based fault injection, simulation-based fault injection and emulation-based fault injection. However, a hybrid fault injection technique is achieved by combining two or more methods. What is basic fault injection testing? In fault injection testing, a fault is intentionally injected into the system under test and the response of the fault-free system is compared with the copy of system under test containing internal faults. And after that, results are compared in quantifying the verification and robustness of the system under test. Recently, fault injection has become a widely used technique for embedded and safety critical systems and applications for testing and dependability analysis. Now the objectives of fault injection tool. The primary goals of fault injection in the design process are divided into two categories: validation and design aid. Validation is further divided into fault removal and fault forecasting. When the objective of a fault injection tool is fault removal, a qualitative analysis is performed to check if the fault tolerant mechanism is okay or you need to improve it. In the case of fault forecasting, fault injection is intended to quantitative evaluate with the probabilistic approach. The coverage of fault tolerance mechanism is evaluated. In the case of design aid, fault injection experiments are executed at several stages of development process. The results of fault injection are then used to initiate an iterative process that allows improving the test procedure and fault tolerance mechanism of the system. Now, development of fault injection tool and environment. When a researcher wants to develop a new tool for FPGA based designs, it requires the three basic building blocks: fault injection manager, fault list manager and result analyzer. Fault injection manager is a critical component which is responsible to answer the three basic questions of fault injection technique. Where to inject the fault means the location of fault. When to activate the injected fault means the timing of the fault, and how to inject faults means the method or a technique which is used to inject the fault in the system. Fault list manager, which describes the what type of fault models you are using, such as bit flip and stuck-at fault model. Result analyzer is a very important component which analyzes the result in different ways. For example, in a fault injection testing, it is used to calculate the fault coverage or the number of test vectors, etc. So this is a basic architecture of fault injection tool is shown in this figure. Now the fault injection technique for FPGA based system. There are 4 fault injection techniques which we have already discussed. The 2 of them are used for FPGA based systems. Number 1 is simulation based fault injection and other one is emulation based fault injection. Simulation based fault injection is divided into 2 techniques, which is called simulator command technique and code modification technique. In simulator command technique, the different simulation commands are used to change values and see the response of those faults in the system. Code modification technique, in which the code is changed by injecting fault in the system, and then we simulate that change and observe the results. In emulation based fault injection is also divided into reconfiguration based fault injection and instrumentation based fault injection. Instrumentation based fault injection is the same as code modification technique, in which we add some component in the original design, and when we activate that component, and we will see the effect of that component. And reconfiguration based is used at the bit stream level, where we change the configuration of the design and we see the effect of that design. So in the future videos, we will talk more about how to develop a new fault injection technique or tool for the FPGA based system at different levels of the development flow. Thank you for watching this video. If you have any question, you can write in the comment section, or you can follow us on our Facebook page and contact with me on this page. Thank you.